Hi, everybody. I sincerely hope that you're doing okay. I know this has been a tough time on everyone. Just take care of yourself, be brave, um, try to stay up to date on the news, but not too much. Take care of your family for sure. Um, and know that this will pass. And you want to be able to look back on how you acted during this time and be proud of the way that you acted and be able to tell your kids and your grandkids when they ask you about it. Um, it's history and it's hard. There's been a lot of people that have been asked to do a lot of things for our country over the years, like go to war um, and sacrifice and do all these things. But my generation has never had to do this, and obviously yours hasn't either. Um, so I don't know, soak it all in, and not all of it's good. There's pain, and we haven't even hit the worst part of this yet. So um, I'll try to be here for you, educationally and emotionally. If you need to talk to me, if things aren't going well, just let me know. No problem. And education can take a back seat for a little while, but you just need to communicate with me. Um, Good news, as far as our 10th grade biology class is concerned, is that we are now in ecology. Ecology is awesome. It's the culmination of all the work that you've done the entire year. Finally, we are outside of the cell, we're outside of the theoretical evolutionary process, and we're going to talk about organisms in their environment. That's all ecology is. There's a lot that you're going to be able to do outside your house over the next few weeks, but there are some theories that we need to hit upon, and we're going to do that in a moment. I think it's best to start this unit with a movie. So here we go. I don't really know if I can't really say anything after that, other than the fact that um, it's sad for the bunny, but it's great for the hawk and the hawk's babies and the hawk's grandchildren. And I hopefully that was shocking for you, as it is for me every time I see it. But at the same time, that's ecology. It's hard. There's a lot of pain and suffering out there in the natural world, and it's all about food and survival and reproduction. Um, Let me go here, and maybe we can start this. There's a few things that you need to know, and if you were able to get out a piece of paper and write down a few notes, I'd like you to do that. Um, I want you to look at the left, I guess it's the right side of your screen where it says schnapps, and understand that these six atoms make up 96% of all the matter that exists in living organisms. Carbon is at the top there. There's hydrogen, oxygen. Those are the three major ones. Um, that are used, the major atoms that are used to make all of these sorts of biomolecules that you learned about in the first semester, like proteins and fats, um, carbohydrates, nucleic acids. Then we also see nitrogen's important, phosphorus, and sulfur. But I would say commit that to memory for sure. I'd like you to write that down, and I would like you to write down what I'm about to show you. This is my board from last year that I just took a picture of, and I always do that to try to remind myself what was good about last year when I presented this material and what I could change. So I'd like you to draw this circle that I'm about to reveal here on the screen. And I want you to write next to it matter cycles. And that little baby bunny had a lot of matter inside of it, lots of carbon and hydrogen and oxygen, among other atoms. And that's what we mean by matter. Matter is something that has mass and takes up space. And that matter is going to cycle through the bunny to the hawk, maybe to the hawk's babies. And then eventually, those organisms are going to die. And those atoms are going to be reintegrated into the ground. And they're going to come about, again, those same atoms in plants. And then bunnies, 10 years later or 10 months later, will then eat the plants that contain the atoms that were once in that original bunny that we saw run across the grass there. It's a pretty brutal system, but it's the same way that it is with us. Your atoms have been circulating through birth and death and dinosaurs and birds and plants and probably stuck in rocks for millions of years. But they've all been released into plant matter, which has then either been eaten by you or eaten by things that you've eaten and then integrated into you. And when you go, all those atoms are going to go back eventually into the ecosystem. And then, 1,000 years from now, you could be soaring over the Grand Canyon in the body of part of you in the body of a bird. I just want you to think of matter recycling. It just recycles. These atoms are in a constant state of use. Well, probably the easiest way to outline this is through the carbon cycle. So there's a ton of carbon dioxide which has carbon in it. It's a molecule that with two oxygens, one carbon atom, and it exists in the atmosphere. We know that through photosynthesis, bacteria and plants and prokaryotes and other organisms take in this carbon that exists in carbon dioxide and they assimilate it into something that we call glucose. You've seen glucose before in the first semester, same with photosynthesis. Make sure you write down C6H12O6. That's the molecular formula for glucose. You probably then remember as a result of cellular respiration that we take the glucose from the plant material or animal material that has eaten plant material, and we try to utilize the energy that exists in the bonds between those atoms. That's through cellular respiration. And then the ultimate goal, of course, is to make ATP, but also get some of those atoms to build mass and help us grow and repair things in our body. But you can see way up there in the top left corner that water is released, and when energy is released, it's released. We use it, but we lose it through inefficiencies out into the environment. And the point is that the carbon that we once brought in as food, as the base of the food pyramid in glucose, is now released back into the ecosystem, specifically the atmosphere, as carbon and carbon dioxide. And it's a circle. Make sure that you write this and you commit this to memory. We are going to come back to this for sure. I'm going to show you one more movie, and then we're going to go over a couple big picture items.
All organisms living in an ecosystem, such as the African savanna, require energy and nutrients in order to carry out essential life activities, such as growth, respiration, and reproduction. On the savanna, as in nearly every ecosystem on Earth, sunlight provides the energy that powers life, while nutrients and other critical building blocks of life, such as carbon, hydrogen, phosphorus, and water, enter the ecosystem from the non-living environment, the atmosphere.
That's good stuff. If we were in class right now, I would hand this to you, and then we'd go over the state standards, just so I show you where we're going in this unit. Here's the first one. We're going to analyze how energy flows through trophic levels, and that's a very, very important thing. I want you to write this down. Energy flows. It flows. It flows from one side and goes out the other, and we're going to get to that in a second. That's different than matter. I don't like this state standard, and I think that it's wrong, to be honest with you. It says explain how ecosystems follow the laws of conservation of matter and energy. Now, matter is conserved, it's recycled. Just as the movie just said, there's only a certain amount of carbon on the planet. It's going to be recycled again and again and again. But there is no conservation of energy. The whole idea is that energy is limited on the planet, and we need a constant supply of new energy all the time. And so I don't. That's just flat out wrong. There is no conservation of energy. We'll get more into those details in a second, and over the next few days. The last state standard I want to show you is this one. Discuss the interdependence of autotrophic and heterotrophic life forms. So that's autotrophic means self food or things like plants that make their own food. Heterotrophs mean other food like us. They're organisms that are reliant on the autotrophs for their energy, meaning we're going to eat plants. So let me read this again. Discuss the interdependence of autotrophic and heterotrophic life forms, such as depicting the flow of a carbon atom from the atmosphere to a leaf through the food chain and back to the atmosphere. The good news for you is you just drew the carbon cycle. And so that's all they're talking about here is just follow a carbon and how it goes through ecology. I like this picture, and I have these handouts in our classroom to give to you. We see a giraffe eating an acacia tree here, and I want to point out to you that sunlight is coming in through the top. The first white box as you go down says producers are taking that sunlight. They're fusing together atoms from water and carbon dioxide to make glucose. They're holding that energy as that green box in the middle there, the chemical energy. And then obviously the producers are going to use some of the fuel that they've created, this glucose, as well as consumers, like a giraffe. It's going to consume that glucose in the plant material, and then they're going to try to break those bonds through cellular respiration and get the energy from that to create ATP and power themselves through their day. Now, you can see the red arrows going out to the right, and what that's indicative of is the inefficiency of this system, that all of the energy that originally comes in as sunlight is lost as heat. And so, therefore, we need a constant supply of new sunlight. If the sun ceases to shine, all of biology would cease to exist. Last thing that I like about this picture is the blue circle that's going around the outside, and that's just showing that all of the matter or these atoms or these nutrients are cycling. They're used in plants, consumed into organisms, consumed by organisms, and then the organisms and the plants eventually die, go into the ground. The atoms are then used again in the next crop of plants, and so on. This all comes down to photosynthesis and cellular respiration. Remember these two things that you have spent a full unit on in the fall semester. They're symmetrical and they're reciprocal of one another. The reactants of photosynthesis are the products of cellular respiration, and vice versa. I think is the most elegant thing in all of biology, in my opinion. I love it, and it is going to form the basis for this unit. So make sure that you remind yourself of these processes if you need to. The last thing I really want you to do before I give you an assignment here that you're going to be able to do today and then also tomorrow in our online class is I'd like you to draw this. This is an example of a glucose molecule, 6 carbons, 12 hydrogens, 6 oxygens. It's C6H12O6. Go ahead and pause the video and draw this. We're going to be spending a lot of time with glucose. I know that you know what it is from the first semester's photosynthesis and cellular respiration, but here it is again. Last thing I want to show you is our assignment. You know, I'm going to give you. I've made my wife's phone was able to make scans of the textbook pages, and then I put it on the Google Classroom. Go to page 64 in the book's pages and make sure that you do the assignment that's here. So here's page 64. And I'm not going to tell, I want you to read this. So I'm not going to tell you everything about it, but I want you to look here. And the whole idea is that I want you on a Google document to try to show me in a creative fashion where you are in this whole process of ecology. Where do you stand? And I'm not going to say any more than that. You can read the pages. And then I want you to, here at the bottom right corner, I want you to read pages 64 through 68 and answer questions 1 through 4 also on a Google document. Here they are. They're on page 68. Make sure that when you finish this, you do not submit it to me. We're going to submit both of our assignments, this one and then our next one together all at once. Thank you. Make sure that you get in touch with me if you have any questions about any of this. And most importantly, this is a tough time, so take care of yourself and your family and communicate with me through email. I'd love to help you if I can. Thank you.